Hi grade 8s, welcome back to another one of our video lessons. So we're going to continue now on page 132, which is geometry of straight lines, perpendicular, intersecting, and parallel lines. Okay guys, for those of you that had different pages in their textbook, so the two textbook basically swapped section 12 and 10 around, and in the later textbook, which you probably have, that's the right way to do the order, because I feel like we've already been using these results that they're going to show us about parallel lines and perpendicular geometry of straight lines, because we used that all those results in proving the previous problems on the previous page and exercise that we've done. Okay, so basically I'm going to run through it again just as a refresher, just for completeness sake, but you guys are pretty aware of these things already, so it should be pretty smooth and quick. All right, so let's begin. I'm on page 132, looking at perpendicular, intersecting, and parallel lines. We will now look at the relationship between the angles formed by straight, perpendicular, and parallel lines. You have already learned about shapes that are defined by these types of lines. For example, a rectangle can be defined as a shape that has four straight parallel sides and four right angles. Each side of the rectangle is perpendicular at 90 degrees to the adjacent side. Okay. Right, great. Let's look at angles on a straight line. So we know that angles on a straight line add up to 180 degrees. It's very easy to prove. So let's quickly rub off the last lesson. So if we have a circle, right, with center O, there it is. We know that if we draw in a diameter like that, we know the diameter is going to chop the circle exactly in half. And we also know that if we go all the way around the circle like that, that's going to give us one revolution, which is going to equal to 360 degrees. So if the straight line, which is the diameter, chops the circle in half, well, then going from one side of the line to the other is going to be 180 degrees, and then the other bit is going to add up to another 180 degrees. All right, so this is a common result that we use in, I was going to say economics and maths, to find the unknowns and different angles that they're asking for. So remember, always angles on a straight line add up to 180, and also angles in a triangle add up to 180. All right. So it is important to use the correct notation in geometry. In mathematical diagrams like this, the small numbers are not the sides of the angles, but are labels for the angles. So if, again, remember there's two ways to label angles, right? So we could have a straight line like that with angles on it. This could be point B, and this could be 1, 2, and 3. Again, so 1, 2, and 3 doesn't refer to the size of the angle, but rather it says that this is angle B1. So then I could say, well, angle B1 equals to 35 degrees, or whatever it might equal to. Okay. The alternative to this is that we have three-letter notation. Okay, so I could also call this angle B1. I could call it angle ABC. Okay, and I'm wedging the angle by letter B. So it's ABC. There it is, also equals to 35 degrees. So the two notations are really the same thing. It just depends how I present the information for you in the question. Okay. Now, let's say I have a question, and let's say there's another line over there and another line there. Now, I don't have any 1, 2, 3s over there. Now, you can't go there and say 1, 2, 3, and then answer your question saying that, oh, A3 is this, okay? Because I didn't give you that. You made that up, okay? So if that's what you want to do, you have to tell me what A3 is, okay? So let's say that's what you want to do. So this is D. So you're going to have to say to me that let angle A3 equal to DAC. Okay, and then you can continue using A3 if that's what you want to do, but you have to tell me what it is. Okay. All right, anyway, that was more of a side note. The idea here is just how we distinguish between different angles and what notation do we use to call them. All right, but you guys already kind of know that from the previous year. All right, let's continue. So there are different ways to describe the angle you're using. For example, you can describe the angle between the lines AB and BC as angle ABC, or as ABC, or as CBA, or angle B1. Okay, so though all those three notations are exactly the same, the other way is to call it angle ABC. So they put the angle side in front instead of the copy. But again, it means exactly the same thing. You have already learned that the sum of the angles on a straight line adds up to 180 degrees. So in the first diagram, B1 plus B2 plus B3 is equal to 180. When two or more lines intersect at a point, they form vertically opposite angles. Okay, guys, remember vertically opposite angles. We have two lines intersecting. This angle is the same as that angle, and this angle is the same as that angle. Why? Because they're exactly vertically opposite. So that's why it is. The vertically opposite angles are equal. In this diagram, angle 1 and angle 3 are vertically opposite, and angle 2 and 4 are also vertically opposite. We show this mathematically by writing angle 1 equals to angle 3 and angle 2 equals to angle 4. All right, the notation that they used there was basically just the angles because I didn't give you any letter there, so you just say angle 1, 2, or whatever. When two lines form an angle of 90 degrees, we say that the two lines are perpendicular. The two diagrams below show perpendicular lines. Okay, remember perpendicular lines means 90-degree angle between them. In geometry, we use the symbol upside down T to show that the two lines are perpendicular. So in the diagram, AB is perpendicular to CD and EF is perpendicular to GH. The symbol perpendicular shows that they are perpendicular and form the angle of size 90 degrees. Okay, guys, that's pretty easy. That's at bottom page 133. We already know that anyway. Let's go to the next page, 134. There's a worked example. Let's quickly look at that. So angles around the point. The sum of angles around the point adds up to 360 degrees. We call this a revolution. Okay, we knew that already. Let's look at the worked example. It says determine the size of ABC. Okay, we can see from the diagram we have a point B in the center and it has three arms going outside and it forms angles of 85, 110 and the unknown angle ABC. All right, well, how are we going to solve this? We know that we have to use a revolution. So we're going to say that angle 85 plus 110, 85 plus 110 plus the angle that they want, which is ABC. Okay, I personally prefer this notation with the copy in the middle because it straight away tells me it's an angle and I can easily find it with the three letters. But guys, it's your choice which abbreviation you want to use. I prefer this one. You can use a different one. Right, so that plus that equals to 180 degrees. No, I'm lying, not 180. It is 360 degrees. What is our reason? We can say revolution. Okay, and that is enough. Guys, for the reasons, you don't need to give me a half a page essay explaining how the thing works. You just need to tell me which one is it that you're using. Okay, so you could say that revolution, or you could say revolution adds up to three angles in a revolution add up to 360 degrees, or you could say revolution. It's fine. I'll understand what you're talking about. Okay, let's solve for ABC. So ABC equals to 360 minus these two. So this is going to be 195. Take it to the other side. So it becomes minus 195. And that equals 2. It's almost 200. So it will be 160 left. So it will be 165 degrees. Okay. Right. So that is very straightforward. Let's see what they did. Okay. They went a little bit of a long way. But let's see. First, you extend the line DB to D. Okay. We can now calculate the size of angle ABC as follows. Okay, so guys, they are going completely like a very long way to figure this out, because all that we have is this. They have 85 here and 110. I just want to explain what they are doing. They are saying that, well, what we can do is we can extend this line over here, and we can find, that doesn't even make sense. Oh no, it does. Sorry. They extend the line over there, so using angles on a straight line, they can find this angle here, because it is 180 minus 85, so that's going to give us 95. And 180 minus 110 will give us angle of 70, and then we can add those two and get our answer. Personally, I like the way we did it, because that's really quick. There's no need to do constructions and complicated steps. So they've gone through this hassle, but at the bottom they say, notice that when we add up all the angles in the revolution, they add up to 360 degrees. So why not just use that from the beginning? Why go through this long process? But anyway, guys, remember, in geometry, there's many ways to answer the same problem. Okay, there's obviously a faster way, but you can go other ways. There's no issue with that. Right, let's look at exercise 12.1. All right, so 12.1 says write down the vertically opposite angles in these diagrams. Okay, guys, so you have to give me all the vertically opposite angles. So match them up. Angle A1 equals angle A2, angle B2 equals angle B3, and whatever it is. Okay, here they didn't give you the letter, so you're just going to say angle 1 equals angle 3. Okay, and so on. For number 2, in these diagrams, AB is perpendicular to CD. Use this information to determine the sizes of the unknown angle X in each case. Okay, well, guys, that's pretty straightforward. If they're perpendicular, it means it's 90 degrees. So, not a very difficult question. Number 3, determine the size of the angles marked A to D in these diagrams. Remember to give reasons for every statement that you make. Okay, guys, so the reasons that we've got so far is angles on a straight line or vertically opposite angles. Okay, so use those to find your A, B, C, D's over there. Give me reasons for your calculations. All right. Let's continue. So then we have angles on intersecting lines. So a transversal is any straight line that intersects a pair of lines. When a transversal intersects two or more lines, angles are formed at the intersections where the lines cross. All right, so basically they are introducing us again to alternate, co-interior, and corresponding angles. Okay. Right, so let's quickly run through those three. Now, the way they're doing it here is that they first not telling us whether the lines are parallel or not parallel, and they're just showing us how to interpret these angles. And then in the next page, you'll see, or in the next lesson, that what they're going to do is they're going to now tell us that these lines are parallel, and then we're going to have certain implications onto that. So what I'm going to do is I'm going to kind of assume that they are parallel already. So what I'm going to draw is I'm going to have two lines going like this, which are parallel. Okay, they don't have to be, but they are. Okay, and we have another transversal going through the two lines that are parallel or not parallel. Okay, so what this is telling us, okay, let me take these parallel marks off first, and then I'll put them on. I just want to explain. So with parallel lines, there's three types of angles: co-interior, alternate, and corresponding. Okay, each one has a letter to use to remember them. Okay, so we have alt angles. Okay, angles, and that forms a letter Z. Okay, now the Z is here. There's our Z. Okay, so this angle is alternate angle to this angle here. Okay, and the Z is over there. So remember, make your Z and the two angles are the same. Okay, they are the same only if these two lines are parallel. Okay, if they are parallel, the alternate angles are the same. Okay, the next one is going to be cointerior angles. So cointerior angles, and that is going to be the letter U. Okay, so I'll do it like that. Right, so if we take away this, we have the letter U forming over there. Okay, there's a letter U, and there's another one on this side as well. So if these two lines are parallel, this angle there plus that angle there add up to 180 degrees. Okay, so that is known as cointerior angles. So that angle plus that angle is 180. The angles are not equal. You can see this is an obtuse angle. This is an acute angle. All right. And then the last one is corresponding angles. So corresponding angles, and the letter for that is F. Okay. Right, the letter F is formed over here. So there's my two top bits which form the parallel bits. So there's my F and there's my solid bar going down the middle. So here's my F, if you can see that. Now, in corresponding angles, this angle over here is the same as that angle over there. And this angle over there is the same as that angle over there. Okay. So if the lines are parallel, then those two angles are the same, then those two angles are the same. Okay. But in terms of the letters Z, U, and F, that's the different classifications of angles. So alternate angles makes the shape Z, cointerior makes the shape U, and corresponding makes the shape F. If the lines are parallel, then these, for cointerior, they add up to 180. For alternate and corresponding, the angles are the same. Okay. Right, guys, so let's look at the worked example on page 136. So it says, in the diagram, identify these angles. Number one, two pairs of alternate angles. So I'm looking at the diagram, so I'm going to say the alternate angles are the Z's that are formed. So it's angle 2 and angle 8 are the same. And if we can do the reverse Z, so remember, that's the one way Z works, or we could go the reverse way, okay? So we're going to do the same on this diagram. Going reverse, it's angle 3 equals to angle 5. Number two, four pairs of corresponding angles. Okay, corresponding angles is the F's. Okay, remember we can also have, there's the F forming, we can also have the F on the other side. So obviously it's this and that, that and that, that and that, and that and that. So that's the four pairs of corresponding angles. So it's the same as on the diagram that we have. So basically angle 4, angle 8, angle 3, angle 7, angle 1, angle 5, and angle 2, angle 6 are the same. Number 3, two pairs of cointerior angles. Cointerior angles make the U, so that is angle 2 and 5 add up to 180, or rather don't add up to 180 because we don't know if the lines are parallel, they're just cointerior. So angle 2 and 5, and angle 3 and 8 are also cointerior. Okay. Right, guys, so that's where we're going to stop for this lesson. And in the next week's lesson, or actually next week, I'm hoping to see you guys in class. So we will probably carry on in class from there, which will, well, we're going to continue on angles on parallel lines, which is on page 137. Okay, cool, guys. I hope you enjoyed the lesson, and hopefully I'll see you next week. Cheers, guys.